everyone. Welcome back to Energy Visionary. I'm really excited to be joined by two system experts on sub-metering solutions. And in my opinion, this is one of the most important pieces in your system to verify energy efficiency and savings. So without further ado, I'd like to introduce Mike Easton and Peter Sanei from QMC Solutions.
Thanks, Aaron, and thank you very much for having us. We're really looking forward to having this discussion about metering systems, opportunities that we're seeing in the market, and as well as discussing how to tackle some challenges that we've seen in existing and new sub-metering systems.
Aaron, for having me. I'm very excited to be here. I believe this is a great tool that could help us reach a larger audience, our partners, energy consultants, and property managers.
Well, appreciate you being here. Mike, I'll let you take over the controls and show us what you brought us today.
Thanks again, Aaron, and thank you everybody again for attending. So today we do want to talk to you about metering systems for energy management purposes and how you can use that data once it's collected from a good meter system for driving energy savings in your property. So specifically, we're going to do a very brief introduction about QMC. We'll look at some case studies of how we've used good data from meter systems for energy savings measures. We'll talk about some of the challenges that have come up with deploying metering systems for energy management and the best practices for doing optimal system designs and deployments. And so we'll be doing questions and answers throughout the presentation. Just a bit about Peter and myself. Peter joined QMC about 3 years ago with 12 years experience in the metering industry. He's our manager of the QMC's instrumentation division, and he focuses on our BTU, gas, and water metering system deployments. I've been with QMC since 2007, and I'm our VP of Sales for Eastern Canada. I really work with our portfolio clients on designing and deploying large metering systems that meet their needs, as well as for operators, tenants, and their energy management team. And a bit about QMC Metering Solutions. We've actually been in the market for 25 years, and now we have offices across Canada and also recently opened up a US office in San Francisco. We specialize in doing metering systems for all different utility types. So we're a little unique in that sense, in that we don't just focus on one utility type. We offer metering solutions for electricity, water, gas, steam, and BTU or thermal energy meters. And big part of our business now is actually collecting data from these metering systems, and whether we're doing billing or energy management with that data. We actually pull data from about 250,000 meters across Canada, the US, and even in some international locations on a daily basis. The new programs we've been doing at QMC is called our Sustainability Through Accountability program. It's focused on engaging all the different stakeholders that can use meter data to better optimize their energy savings. The first group that we try and utilize meter data with is the actual end user, and that they would be using this data for either paying a bill and therefore having a financial incentive to conserve, or getting more data out of their meter system so they can try and optimize their energy use. Secondly, we work with building operators who are now getting sub-meter data so that they can see how their systems are performing down to a micro level, and therefore take actions to make their systems work more effectively, and also look at that data to do preventative maintenance. And the last group we work with is consultants and energy conservation providers who are installing systems or modifying operations at a building, and we're tracking those the savings that are being generated by those groups, really in a measurement and verification sense. So all of these groups now, with sub-meter data coming to them, actually have the data available to them, and it can now be accountable for driving savings, energy savings at the property.
Excellent. Thanks, Mike. I just want to jump in on a few of these points. And based on experience as an energy consultant, when we do work with our clients, is a bit of a misunderstanding on sub-metering within their own property. A lot of them assume that because they have an HVAC BMS system, that system is somehow tracking their energy usage on particular systems. But unfortunately, that's not the case. And when we go in to help with an energy retrofit, they don't have that data on hand. So definitely very important to make sure you have a proper sub-meter system in place and it's in good working order. So really excellent points here. Thanks for sharing, Mike.
When we start looking into building new metering systems or working with existing systems, one of the first things we need to remember is that meters are cash registers. That's the foundation of why a meter exists. And in 95% of meters across North America, why they're there. They're there to facilitate the transfer of ownership between a utility selling electricity, gas, or water to the building or an end tenant, so that proper exchange of compensation for that utility can occur. So again, we need to remember that the primary function of a meter is a cash register for billing purposes. And that's why there's a lot of regulations as well as some restrictions on what you can do with existing meters. So why we can't just go and tap into every existing meter in the field. It's often needed to be protected as a measurement and billing device first. So we need to be conscious of that whenever we're designing and interacting with existing meter systems.
Yeah, Mike, I really do like this visual on this slide. And even in new construction, a lot of property owners assume they might be getting certain sub-metering where that's not necessarily the case unless it's part of their tenant agreement on how those bills are going to be divvied up. So really important to make sure when you're in design or even taking over an existing property that you have this analysis completed. We were just recently on an older property, commercial complex downtown, and one of the tenants was an old restaurant. And obviously the restaurant was using quite a bit more natural gas in the kitchen and water in the kitchen as well, compared to the neighbors who were a retail store. So part of the investigation was to make sure that the bills were getting split up appropriately. And without sub-metering, it is a bit of an educated guess on how you're billing people. So really important slide to equate sub-meters and a proper system set up to cash flow into your business.
Actually, an example of an advanced institutional metering system we would deploy for a multi-building property, let's say at a campus, like a university, maybe a hospital complex. And what you're going to see is there's a variety of different metering icons, which on this diagram represent existing meters in kind of a light gray color. And in the orange, that is new metering that would be installed to complete the existing metering system. Because often there's holes in the meter, in the existing metering system need to be filled so that a comprehensive metering system is built. All the dashed and solid lines you see from there are kind of the second step of any metering program we put in place, which is the communications infrastructure. And there's no silver bullet for communications and metering systems. You often need to have a combination of wireless systems and hardwired systems. And one of the things we really focus on is making non-proprietary communications installed so that any group in the future can access those new meters that have been put in the field. And the last portion of any good metering system is the collection and use of the meter data. And that's shown on the right side here on our Meter Connect platform, but it's really for any energy management software and reporting tool. And from that system, you can then do a variety of different end uses. As we just discussed in the last slide, billing is the main use of most metering systems. But some of the more advanced features that you're showing here, everything from leak detection to Energy Star portfolio management reporting, are all available from a well-designed metering system. I'm just going to dive into a bit more detail on one of these buildings here. Let's look at Complex A. You can see that we've got 3 commercial buildings in the property. They would have a combination of existing utility meters, which we can integrate with, as shown with a universal data logger. We really like at QMC working with existing meters, especially utility meters, because they're very accurate, they're very reliable, and often because they're already in place, they're very cost effective to utilize, as opposed to installing an additional redundant meter, which can have high material as well as labor costs to install that device. So all of these light gray meters shown here are existing meters that we try and integrate with. And in most regions within Canada, we're quite successful at doing that. New electrical meters would probably need to be installed in quite a few of the properties. And whether that's to break out tenant loads or to break out critical electrical loads within the facility, we would aim to install those new meters and connect them to the same data logging equipment that we're getting the existing metering data from. And in this example, we're showing a cellular connection to that data. We've really been utilizing a lot of cellular connectivity for systems because it's cost effective. It allows us to get pretty much 98% of Canada is covered with cellular coverage. So there's very few locations we can't get connectivity to. And it also is a very secure way of getting your data and doesn't require us to get involved with IT teams at site who might want to have firewalls and other boundaries up for us not to be able to easily access our meter data. So cellular is one of those technologies we use a lot. You notice here in the middle, we've talked a bit about quite a few of the different protocols available too. All of these being open protocols, MBus, Modbus, and BACnet are the three primary communications protocols we see in Canada for metering systems.
Excellent, Mike. No, I really like this diagram. It really clarifies, how the system should be set up. And from a design point of view, what phase of drawing package would you suggest, QMC be involved to help integrate your submeters? Is that about the 60 or 90% range of design packages?
I would say the earlier the better. So 60 would be ideal. We find that the earlier our team can get involved in what we call the meter plan, and I'll actually bring that up on our next slide here, is the earlier we can get involved, the better the metering system should be designed and deployed, and the reduced costs in the long run, because if we get in late in the design of the system, there's often adders or modifications that need to be made to not only the meter system design, but also the labor and other systems required for a good metering system to be deployed that really bring up those costs if we come in late to the game. So we do like to be involved as early as possible in the system design, whether that's an existing building in a retrofit project, or we're talking about a completely new building and working with the engineers in the early design phases of it. But one thing you'll see here on our keys to a good meter deployment is a real meter plan. And that's often what doesn't happen, and it historically hasn't happened with meter systems. They tend to get deployed only as a meter, like, oh, we've specified a meter or we've ordered a meter, so it's fine. But because advanced metering systems now need meters to be integrated with so many different end systems, whether it's the BAS or an EMS, and there's multiple contractors and engineering teams involved because you're talking electrical, talking mechanical designs. If we can get in earlier, it makes this whole process so much easier. And so in the second point here, we really do like to consult with the property managers as well as the energy managers at the same time, if not before even the engineers, because we want to understand what the end user wants from the system. And then we can specify what hardware and communications and even software they need moving forward.
So yeah, I was going to mention we typically would like to get involved when the plans are submitted for permission, for permitting process. That's usually at about 50-60%. And then we usually stay actively involved until the planning and the drawings are complete. And then we would keep being involved during the construction phase and deployment phase. And then afterwards to verify the system and make sure all metering equipment are communicating and we're getting good quality and reliable data.
No, that's a really good point, Peter. And like I was thinking as well, definitely bringing you guys on early to make sure everything is working as designed and we don't have those extras during construction that sometimes you get during change orders when all of a sudden now we want to add submeters. So really good point to bring you on early. Also, just curious, does QMC offer in-house engineering that can work with our designs during design to help implement the icons and the specifications?
Yes, yeah. So we have in-house engineering teams that assist our consulting partners with the initial design, and whether that's helping write specifications or that's adding details to drawings so that they answer all the questions that contractors have during the bidding phase. We're very happy to help facilitate that.
Excellent. Yeah, that answers my question. Thank you.
Also, we do assist consultants when it comes to writing scope of work for different trades, whether it's for mechanical or electrical contractors, to define all aspects required for metering so nothing is missed, so there's no problems down the line during the deployment phase.
I'm wondering if you'd be able to provide downloadable specifications that we could have for our Energy Visionary members inside the platform, if that would be something you guys would be willing to share with us.
Very happy to do that. And one thing we found historically has been a challenge with a lot of consultants is bridging that gap between the electrical side and the mechanical side, because almost all of the systems we deploy now have multiple utilities in them. So you need to have that integration between the electrical metering, which has historically been the majority of metering done, along with these new mechanical systems that are coming into place, whether it's DTU, water, or gas. And then there's the entire communications infrastructure as well, as we were just discussing. So our specification that we can make available is actually a multi-utility specification. And whether it sits in the electrical side or the mechanical side, it's usually dependent on if there's more electrical or mechanical metering. But we will make that available to your subscribers.
On top of what Mike mentioned, it's also important to know which stakeholders are interested in the data. In newer properties, there's usually multiple stakeholders that need access to a certain set of data. It's very important to know the requirements and who this data should be flowing to, whether, for example, for new buildings where you have geothermal systems and you have a ESCO revenue sharing model, and the metering equipment could also be used to help with the operations reporting to the BMS system. Also, they could be used for consumption tracking and revenue purposes. So all of this could be an all-in-one solution. If we're informed in advance, we can design the system in a manner to be able to report the data to multiple stakeholders as per their requirements.
No, that's a really good point, Peter. I'm glad you brought that up. Thank you.
Another aspect of a good metering system that often gets forgotten or neglected is the services around a good metering deployment. Meter hardware is obviously critical for any good metering deployment, but the services around it, whether we're just talking about the consulting and design stage, but often after the meters are shipped to site or in a retrofit application where there might need to be a site assessment done, having competent and experienced meter technicians and engineers available is only going to make the meter deployment go that much better. And so this is a lot of the services that we offer at QMC, as well as other metering vendors do. Everything from a site assessment to assistance during the installation process. Meter inspection is critical. If it's a billing meter, in most applications, you actually need to have a Measurement Canada approved and accredited service technician come by and verify the meters were installed properly, because a bill will be completed or utilized from that meter system. Even if it's an energy management system, we still recommend that an inspection is done of the metering system so that the data coming to an energy manager or a third party for M&V verification is accurate data. And then there's obviously an integration piece here, because the meter systems themselves need to go to a software platform. So you need somebody to commission that the meter and ensure the data is flowing to the end user system. And then a good closeout is all the complete documentation, the verifications we discussed, as well as drawings and everything, so that the property can utilize that system for the next 5, 10, 15, or 20 years.
Excellent, Mike. And just based on experience, actually a school we previously completed, we did have really good feedback from the user group on the owner training that QMC provided, where it was the live access to the Meter Connect software. And that's part of the most important part of closeout and commissioning, is making sure the building operators understand what they have in their system. So if they have particular information coming in, they got to know why it's coming in and where they should look for it. So really good point to have this turnkey solution.
I appreciate you bringing up training, because that was a very valid major part of the closeout. And this is the most important thing, is the meters themselves are really just a way of getting good data for somebody to either do billing or energy management with. So if they're not able to access that data and trained on how to use it, the meters are really just an expensive coat hanger in the end. So we want to ensure that in the end, the data is getting to the people, they're trained up on how to use it, and then most importantly, they're using that data for billing or energy management purposes, because that's what the meter systems are being bought and sold to do.
Wanted to give you an example of one of my recent experiences with a commercial property downtown Toronto that we were brought into late last year to assess the steam metering that was deployed about 3 or 4 years ago on site. While we were going through the assessment, we realized we were initially called in because the total amount of steam that was being built to the property by the district energy was not lining up with steam consumption that their sub meters were showing. And upon further investigation, we found out that the meters were not sized properly, as most of the consultants and engineers in your audience know. Steam meters, one of the biggest challenges with steam meters is that they usually have a very limited measurement range. So it's critical to size the steam meters properly. This particular example in this property, the meters were oversized. As a result, they were only measuring the top end consumption, missing all the bottom end consumption. So the bills were only lining up in 1/4 out of the 12 months of the year in wintertime, when the consumption is really high, missing all the low end consumption. And now they're realizing they've lost that revenue for the past 3 or 4 years. And now they have to go through the difficulty of, reconciling with their tenants and, court battles and all the stuff that I'm sure you're very familiar with.
No, that's a really powerful share, Peter. And for anyone listening, obviously a district energy system is a centralized utility power station that will feed, like you mentioned, steam to a property through a heat exchanger and essentially heat a property using that source. So definitely having the right size meter in that instance costs that company quite a bit. So really powerful story. Thanks for sharing with that.
So I wanted to talk a bit about meter hardware. We could do an entire presentation on each different utility types metering equipment, but we wanted to just give a high-level review here of some of the technologies you're seeing in the market. Starting in the top left, this is an electrical meter that is referred to as a multi-point meter. And what this box allows you to do is meter multiple electrical loads out of one single device. So this meter in particular will do 8 3-phase 4-wire loads, whether that's at a 347-600 or 122.8. And what it allows you to do is very cost effectively meter several tenants or critical loads within the building out of one device. It reduces your material costs and your labor costs. And what we also wanted to show here is that we really do want to focus on non-proprietary systems. And so we've listed this meter in particular because it's a BTL listed or BACnet Testing Laboratories approved meter. That means that really any group, whether it's QMC, another metering provider, the building automation system, or an energy management software provider, can integrate with this meter very easily. So one thing we're really trying to focus our customers on is going with non-proprietary hardware. The meter below it, just wanted to showcase that metering is evolving very quickly, in that these old socket meters that you typically wouldn't think much of, a lot of the newer ones actually have cellular connectivity built right into them. So you can plug in this meter if you have 4 or 5 meter points in a property, and you see the old glass meters that somebody has to manually go and read once a month or once every 6 months. We can pull those out and put in a digital socket meter, and immediately it communicates to a cloud-based solution for $2 or $3 a month of cellular fee. it's an incredibly cost-effective way of getting automated data. On the top right, you see a cellular-enabled water meter. This is obviously for a smaller load, but this can be for 6-inch, 8-inch, or 10-inch meters as well. This allows for really cost-effective deployments for tenant metering or for critical load metering, and irrigation is a great one for this solution because the meter point might not be anywhere near a mechanical or electrical room where you could connect that meter to a data logger or other infrastructure. This allows for a completely standalone solution. That device there is the cellular device actually has a 20-year battery life. So once that meter is deployed, you really don't need to do any maintenance on it for a very long time. And BTU metering is gaining a lot more momentum in Canada. This is because of the more frequency of seeing district energy systems or the provide heating and cooling to multiple buildings, or central plants within a building that are providing each individual tenant space, such as condominiums, with heating or cooling energy. And so you use a BTU meter or thermal energy meter to meter the heating or cooling load within those areas. And one of the reasons that BTU metering is becoming more of a critical issue these days is Measurement Canada is now regulating BTU metering, whereas historically they've only regulated electrical and gas meters. So now with Measurement Canada regulating BTU metering, properties need to ensure that the meters they have in place, in particular ones that are used for tenant billing, are accurate and that they meet Measurement Canada standards, not only for the hardware, but that somebody has come in and commissioned that system. And by 2025, all existing thermal meters need to be Measurement Canada approved. Otherwise, you are essentially breaking the law if you're charging tenants with non-approved equipment. So there's a few more years for properties to get the right equipment in place, but it's definitely driving and more accurate thermal metering systems into the market within Canada.
And I know you mentioned we could spend quite a bit of time looking at the technicalities of each of these products, but I just wanted to jump in on the water meter for a minute. And I know based on what municipality you're part of, you can get a credit for irrigation systems that have a meter installed so that they're not going to the sewer and the city doesn't have to treat your water. So maybe quickly touch on that, but definitely something to think about to get that extra meter installed on your irrigation system.
Different municipalities and different regions now have different regulations. Within the city of Toronto, now there's a mandate that you have to meter your discharge water. That could be groundwater, stormwater, rainwater, or anything that's not coming out of the city supply lines should be metered and tracked and reported on monthly basis. Daily data intervals to the city. There are incentives in Western GTA area now in Kitchener-Waterloo area for sub-metering and tracking tenant consumption and reporting that back to the region. So this is becoming, again, while water is not, as Mike mentioned, is not a regulated commodity currently in Canada, depending on the region that you are in, there could be various incentives to track water consumption. Also, Mike mentioned about some of the advantages of the cellular solutions that we offer. When we do cost analysis very frequently, comparing the cost of a centralized data collection and connecting these new water meters, that whether it's a regulatory requirement or it's the property owners or the consultants wanting to track a specific load, when we consider the cost of wiring these new meters now to a centralized data collection location compared to the cost of these cellular data modules, more often than not, even including the cellular fees that you look at, the cellular solution would come out as a more favorable solution, just looking at the cost aspect of the deployment.
That's a really good point. And I'm aware that there were socket options. So really good to know, especially for high-rise tower applications.
What we just wanted to do here on this slide is summarize some of the challenges we come across with metering systems. and the solutions we bring to that. So first of all, stranded assets. That's where you've had a meter system deployed and that meter hardware is no longer usable, either it's older technology or just was never set up to do remote communications. So instead of leaving that equipment not accessed, what we do is we connect with that using either module adds to the meter to get an output, whether it's Modbus or BACnet out of the meter, and putting in a universal data logger to collect that data. Incomplete projects are really, as we were discussing in the last slide, where the process hasn't been done well around a meter deployment and the meter hasn't been commissioned or integrated. In that case, we need to have our team go to site and connect to the meter with a variety of different technologies, as well as integrating it with the software. Proprietary systems is definitely a big challenge that metering has had over the last few decades. And one of the first things that our commercial properties in particular asked us to really start moving away from in about 2010. And this was where meter manufacturers often make proprietary systems. The problem with that is when the system is completed, if the property isn't satisfied with the services provided by the meter vendor moving forward, they're really stuck with that metering system and that vendor because nobody else can access the data. So what we've done gradually is not only move our own systems around to open protocol non-proprietary systems when we deploy them, but we're able to access proprietary systems with universal data loggers. We've written code to get that meter data out of them and then into a more open protocol format to pass that data on to other groups. Manual processes, so manually going and reading meters is fraught with challenges. You have meter data entry failure and human error. And most importantly, you're also losing all the good data in the meter, like interval data. So what we do is either access those manual read meters or replace them with digital meters so we can get interval data out and do the energy savings activities that we're discussing today. And lastly, if you have legacy systems in place, these are often older meters that are really relying on pulse outputs. Almost all meter manufacturers make a meter that gives a pulse output. But the problem with pulses is they don't give us great reliable data. You're essentially getting a pulse per liter consumed or per kilowatt hour. And if we lose connection to that system, briefly even, the meter register itself will never line up with the data that we're seeing on the system, even once a connection is remade with the meter. So we're aiming to move all of the metering systems we come across into what we call register reads. So the data we're receiving is the same as the visual display on the meter. And that way there's never going to be a discrepancy between what the automated system or billing system is seeing and what the meter itself is showing.
So if I may add sample of what we have come across at QMC a couple of years ago with a proprietary system with one of the universities with about 80 or so buildings in Toronto. They were really dissatisfied and fed up with metering provider within the campus, and they were trying to integrate the data within the BMS systems on campus, and they found out that that metering provider would charge them some really hefty amounts in order to give them that access. And after doing a cost analysis, they ended up replacing all meters throughout all 80 buildings within the campus. That just goes to show it is very important to have non-proprietary system with open communication protocols to be able to give access to different stakeholders as the direction for the property changes.
No, that's a really good point. And on the consulting side, we are seeing similar feedback that they don't want proprietary, they don't want to be locked in. Obviously, if you provide a good, reliable service, they will stay with the system. So a really good point not to get locked into proprietary.
I wanted to go over periodic verification requirements for existing metering systems, as well as Mike went through what's required for a good metering system. After deployment, a part of our closeout process is the education for the operators within the property of what maintenance requirements are there for each type of metering that is deployed within the property. Because these meters are being used to track energy efficiency or do revenue sharing with potential tenants or owners, multiple stakeholders within different properties, it's very important to maintain the meters as required by the manufacturer, also based on site conditions. We have example of couple of meters that are extracted out of a few properties recently within the past couple of months out of our Ontario office. The top meter, as you see, that's a domestic hot water meter that has been in service for less than 5 years. First place, it's worrisome because this is on the domestic hot water system, so it's the drinking water, and it raises questions about the water treatment system within the facility. But also, this is a meter that is being used to track consumption for billing purposes as well. So we were called into the property because cold water feed into the domestic hot water system along with the hot water outlet and the recirculation water were not adding up. So we went to the property with a set of clamp-on meters to verify the performance of these water meters, and sure enough, there was a huge discrepancy between the measured value of the clamp-on meters that were installed out in the field temporarily and the permanent meters. And as the meter was extracted to see what's wrong with the meter, as you can see, there's a lot of built up within that water meter. Also, the picture below that is a BTU meter. That's the inside view of a BTU meter, and this is another challenge within the hydronic systems and in multi-residential buildings. More often than not, water quality treatment within the property is not great. It's either manual or it's not being maintained and tested as it should. So the right chemical are used to treat the water. As a result, in all cavities within the system, you're going to have either sludge buildup, or in this particular case, we have metal shavings built up within the body of the meter itself, which affects both the performance and the measurement accuracy of the meter, and also the longevity of the meter as well, and how long it should be working, the lifespan of that meter as well.
Yeah, those are definitely powerful images. I'm just curious, how often should a building operator be completing an internal check of a sub-meter?
So it really depends. It depends on the utility type and the meters that are deployed for that particular utility. For example, for water, we are trying our best now for more critical and larger loads to move away from meters that have moving parts, because as you know, with moving parts, you're highly dependent on your water quality, and if your water is hard and it has calcium in it, you're going to have buildup, and eventually your impellers are going to get stuck or are going to get damaged. So meters, for example, with moving parts, we usually recommend biannual, every other year, to be verified by the property. With same thing with thermal meters, if they're using measurement principles with no moving parts, so no impellers and such as mag meters and ultrasonic meters, those require less rigorous maintenance regime. So those are usually maintained and verified every 5 to 10 years, versus meters with moving parts, and depending on the load, they need to be verified every year or every other year. So it really depends on the type of the technology that's used for that particular meter, and also the site conditions.
Excellent. So definitely for a property manager who recently took over an existing property, I would highly recommend getting those condition assessments completed. So really good points there. Thanks, guys.
The things we really believe is critical to the deployment of a good metering system is a front-end platform that allows multiple users to access it and utilize that data easily. Historically, metering data has been going to older computer systems that don't allow numerous people to access it. There's one person on site who remembers the password and is able to get the data. And the reporting tools aren't that effective in the end. They're really just made for producing bills, not on the energy management side of things. So we've deployed something called QMC Meter Connects, and it's a cloud-based platform, very similar to a lot of other products in the market, where meter data is going to a cloud-based solution. It just really allows so many more users to get to the data easily, and it allows for immediate updates. So any new features we're able to add to the system are now available immediately to any of our customers. And what you'll see on this system is it gives a very high-level view of any given property, and you'll see throughout this demonstration allows you to go into a really detailed view of any individual meter at the property down into its interval levels. So our dashboard here as an example shows a variety of different buildings within a portfolio, and a quick synopsis if we're looking at building one of if its energy consumption is increased or decreased over the last 30 days for any given utility. It also generates an energy use intensity, so you're able to benchmark your buildings against each other. And also, if the information is available and the upload is set up, you can get an immediate Energy Star score on that property as well. I wanted to show you an example of something that one of our key clients utilizes this platform for, and that's for monitoring their main incoming steam load, because if they hit too high of consumption or demand on that steam load, they're actually charged a penalty by the local steam provider for having to provide that amount of steam any given hour. So they use our system to alert them on when they're about to hit that threshold. We've set up a system where an email is sent to the building operator when they get close to hitting that threshold. Yeah, so what immediately pops up is the last 30 days of consumption for the meter, but zooming out, you're able to see up to 2 years of consumption for that meter. But what I've done is dragged out to pretty much the last year. And you can see this line set here. This is the threshold that the property is set, not the level that they receive a penalty at, but when they want to be notified so that they can make modifications to their steam use at the property and avoid that penalty that they receive at 35,000 pounds. And we can see the last time we received an email and alert status for the property and for their operators to take action was actually back in this December. So I'm just going to zoom in a little bit closer to that week, and you can see that they had, and to this day, December 17th in particular, you can see that they immediately, early in the morning, started getting towards that threshold mark, and an email was triggered to them very early in the morning at about 3 o'clock. And their operations team actually made modifications to gradually bring them back down under that threshold. So they received a few emails that morning saying, hey, you're above your 30,000 threshold. But because of that notification, they were able to avoid hitting their 35,000 pound penalty that they received from the local utility. Just while we're on this, you can see that the amount of steam consumption drastically reduced for this property moving forward, because in Toronto, we actually went into a lockdown phase as well as the Christmas holidays. So you've got, if you actually look at their consumption over that period of time from when they hit that threshold, we actually went down into lockdown and holidays, and their consumption even during these colder winter months is maintained very low because the building has actually been shut down due to lockdown. I just wanted to show some of the more advanced features available on cloud-based systems as well. They integrate weather data in. So very easily you're able to bring in a weather profile, and you can see kind of in the light blue here any times that temperature was below 0 degrees Celsius. And that's when those days are the ones obviously that you're hitting those higher steam consumption to heat the building. So there's a lot of neat tools available in cloud-based systems, because you're not only able to pull meter data, but data from Environment Canada as an example. We can get data brought in for, if provided by the property, on occupant use. So again, you can run regression models around the energy use per occupant in the building. That would be a good model to run actually, because of the lockdowns we've been going through. But I just wanted to show you that example of how we integrated with a main utility meter put that data up on our software and how it's able to drive savings or at least avert costs of the property.
Yeah, this is a very good visual representation tool for a user. And again, just want to mention some feedback we've had on site with these types of software platforms. You know, if the training wasn't completed successfully and the users don't use it properly, they'll be getting alerts and not know what to adjust or what. So definitely having a partner that will educate and ongoing support is critical in this type of platform. So really, really insightful tool though, when used properly.
Aaron, I'd really like to show you another example here of the importance of sub-metering. And this is going into the building and breaking out a variety of tenants in the building, because often commercial properties build tenants on their square footage, which if the tenants are of similar usage, that makes a lot of sense and saves on doing a metering deployment. But we're finding so much these days that tenants have varying uses, whether some have very little energy consumption, others, their neighbor might use a data center or run a 24-hour call center and have varying operating hours. So the energy use between tenants can vary quite substantially. Just wanted to show you an example here of this building. We can see that they have a variety of, on this platform, the highest users within the building are actually shown here on the right side. And these panels each represent a different floor. It's the lighting and plug panel of each floor that was metered. So you can see some of the floors use very little use during a 30-day period, where some of the tenants can use an exceptional amount more, in some cases up to 5 times more than another tenant. And for them, paying the same amount would be very inequitable. So I'm just going to show you this in a bit more of a different format here, where we take this tenant. I've excluded the first tenant because they're actually, or the first floor, because it's a retail floor. But if you look at the remaining tenants over a 30-day period, you can see the complete difference in consumption there. You know, maybe in a pie graph format might be a better way of viewing that. You can see these, you know, tenants on the 7th floor and 5th and 8th floor, as an example, use an exceptional amount more, 18% in this case of the total tenant office use, 27% in this tenant. And at one point, they were all paying the same amount based on their square footage. So this, again, just gives a really good insight as to why it's critical to meter different tenants so that they actually pay their right amount. And also, this gives a financial incentive to the tenant to actually conserve, because now they're paying for what they actually use. This is going back to our sustainability through accountability slide. This tenant is now accountable for what they can consume. So if they want to go in and actually do a lighting retrofit in their space, they'll actually see that savings and hopefully drive down this bill that's quite a bit higher than the rest of the tenants in the building. And another just useful tool is you're able to actually go to actually look at the different profiles of these tenants to see where they're consuming. So that's a 30-day look. But if you want to drill down and actually look at a tenant's consumption over just a daily period, what this will do is show their profiles on an hourly basis. And you can see those larger use tenants really are consuming a lot overnight, whereas the smaller use tenants are ones that are actually shutting down their loads in the evening hours. And you can see that here in the morning loads that are very low for the low use consumers, and the high use consumers are consuming pretty much 24/7. So that's, you know, that would be something that the energy manager, the property manager, even the tenant can try and modify their consumption and get some savings.
Excellent. I know this is a very powerful tool and we could go on quite a while, but definitely feel free to reach out to Mike or Peter on this platform, and they will be able to tailor it specifically and show you demos for your property type. So definitely a ton of different tools within this software. So thanks for sharing, Mike.
You're welcome.
Mike, I just wanted to take over and go over a quick case study. This is a screenshot of a water meter consumption that was extracted from our cloud-based platform. This is a water meter within one of the tenant suites, and as you can see, we are looking at the red lines are the hot water consumption, the blue lines are the cold water consumption, and as you can see, it starts spiking up around the 1/3 of the graph, and the consumption keeps going up until the point that we notify the customer that there is an issue and they start investigating. So this particular one is, believe it or not, it's just the leaky flush in their toilet, which is causing somewhere around over 100 cubic meters of water during this period shown here. And as soon as the tenant was notified and they remedied the issue, you can see the consumption drops back down to the normal level. Now imagine if you had in a 400 unit multi-residential building, you had 5 or 6 units, it amounts to a lot of leaked water that is wasted and causes additional water cost for that particular tenant or occupant. So we've actually built specific alarms around this case study to alert any potential user that you may have a leak within your property and you may want to start doing some investigation.
Yeah, this is also really critical for irrigation systems as well, and why we've been putting a lot of metering on irrigation, because you can imagine a leak in a 2-inch or 3-inch pipe would just cause massive costs, as well as just the environmental waste from that.
Yeah, absolutely. We're definitely seeing an increase with our clients wanting a better visual of their water usage and how they can lower those costs. So with this type of dashboard, it's definitely the way to go for sure.
Another example of a case study tracking thermal energy consumption. On the top graph, we're looking at the data extracted from the BTU meter or thermal meter within the fan coil unit. On the bottom graph, we're looking at the electrical consumption within the same suite. So drilling into the top graph, we're extracting supply return temperature with flow rates along with the demand in kilowatt hours. You're looking here at the top, on the top graph, at the red and the blue lines representing the supply and the return temperature overlaying on top of each other, along with relatively flat thermal energy demand. And when you overlay this on the electricity consumption within the same suite, when we started analyzing this data, we realized that the actuator within the fan coil was stuck. It wasn't opening and closing. That was the reason that supply and return temperature were very close within that unit, and the electricity consumption within the same period was spiking and it was going up. As soon as the fan coil manufacturer sent a service person in order to service that stuck actuator, you see the thermal energy on the top graph, the demand going back to its usual behavior, and then you start seeing a difference between the supply and return temperatures. And when you look at the bottom graph, electricity consumption track within the same period of time, the electricity consumption is dropping right after the actuator gets serviced. So this is another very great example of what else we can do with the granular meter data that we're extracting.
Yeah, and what's really happening with metering is the first example we showed you was a very large meter for an entire complex. The last two have been tenant meters, and the ability to drill in and get this data from very small meters, but hundreds or thousands of them at site, you can find a ton of energy savings just by drilling into these smaller loads, as opposed to where most energy management has been done, which is at the really high level of entire building loads. So this is the amount of data we're gleaning from these systems now is immense and very powerful.
Yeah, absolutely. That's definitely a really good point, being able to drill down onto the individual systems, whereas before you'd have to just visually inspect and assume you were operating as intended, but this really gives you that visual. Like, this is a very, very powerful tool for sure.
Well, and the tenant in particular here was also suffering. They weren't getting heating or cooling, and they were getting slapped with a major electrical bill because their fan was just running, pushing no additional heating or cooling into the unit. So they were uncomfortable, and they were paying 80 to 100 extra dollars a month while they were waiting for this thing to be rectified. So it's, you know, you imagine, as Peter was saying in the last example, there might be several units within a building that are experiencing this challenge. I'm going to show you guys one more sample of a meter that we were picking up in a lead building. It's actually an older example from 2011, but it's still a great example of how we use interval data from a meter for great visualization and actually acting on a load and improving its use. This is it mentioned a lead project, and when the air handling unit that this meter was monitoring was installed, in the summer months, it was actually operating 24/7. And in this heat map, red indicates a very high energy intensity. So for every day, it was operating midnight to midnight at a very high rate. It's shown in the deep red here. At some point in early October, a service technician came in and set the on and off points to the handling unit to closer to operating hours. So you can see it only came on at about 6 in the morning and was shutting off at about 6 at night. And you can see these thin green lines here on the heat map indicate the weekend days as well, where it was completely shut off. So the system was operating the way it was expected to. And actually the M&D consultants we were working with contacted us later on to dive further into the data because this load was not operating properly in total. And when we started drilling into the data again, you could see that at some point there was a manual override done to the system. And again, it was operating at a medium intensity this time from midnight to midnight over the weekends and completely not on schedule. So this was alerted to the staff, and they made the changes to get it back in operating conditions again. But what we really like about heat maps and their ability to use interval data to quickly see the performance of a load over an entire year if necessary and optimize its use. So you can really get some good energy savings once you're alerted to what's happening in the property.
Well, thanks again, Mike and Peter, for presenting for our Energy Visionary Network. Definitely feel free to reach out to either one of these gentlemen to get a more specific and detailed plan for your property. We know each property is definitely unique. So once again, thank you for presenting, and thanks for being with us today.
Thank you very much, Aaron, for the opportunity. Thanks to your viewers for attending.
Thanks, Aaron, for having us, and looking forward to future discussions.
Absolutely. Enjoy your day, gentlemen.